This makes sense if you think about my function is sloping, has a positive slope, and then it has a negative slope. That's how a local max would look. And a local min is a place where f prime of x changes signs from negative to positive. And that, if you think about it, may make sense as well, because right at the place where I would expect to see a local min, the first derivative goes from being negative to suddenly the first derivative is positive. Now, I'm assuming here that the first derivative exists. If the first derivative doesn't exist, you can have lots of different scenarios about the sign. So this only makes sense if we're actually looking at f prime of x being there and actually having a value. But for a smooth function like we typically think about in physics or chemistry or engineering, this is what you're thinking. Yeah, an inflection point is a place where f double prime of x. So please take your green marker and make a huge cross out and write f double prime of x in place of f of x. Make it like glaringly obvious. This should be, inflection points have to do with f double prime of x. But notice both of these things are about changing sign. Local maximums and local minimums change sign in a particular way. Inflection points, the second derivative just changes sign. And so there's a process that we can always follow to determine if a function changes sign, and it's called the sign chart process. So we make what's called a sign chart. And we've done this before, but I don't think I've ever given you the written instructions, and it may be helpful to some of you to see it as an actual procedure. So we're going to try to do this. Notice we can do this for the first derivative and get local max and min. Do it for the second derivative and get inflection point. So